Yes. Now the microphone input volume is increased. Let me share the screen. Janessa, Janessa, only 2 more minutes. Janessa, could you hear me? The microphone input volume is now adjusted. I'm sure now you will be able to hear my voice. Janessa, can you please join? Janessa, am I audible? Could you hear me? Could you hear me? Hello? Hello? Janessa, am I audible? Hallelujah. Hallelujah. Mic testing. Could you hear Janessa? I'm sure here I'm getting the signal that the microphone is now okay. Audio is okay. Janessa, and there was some audio input problem. Now it is rectified, and Janessa could not hear my voice because here the input signal volume was 0. Uh, it was the settings were changed. Now the audio is fine, Auntie. Okay, Auntie. Janessa can join, please. Thank you, Auntie. Thank you, Anta. Please request Janessa to join. The link is active. Ah, ah, thank you, Auntie. Acha, acha, very good. ఉంటాను, Auntie. We'll continue. Thank you. Janessa, am I now audible?
Yes, sir.
Praise God. Because the input, it is the problem with the input signal, Amma. The input volume was almost zero in the settings I changed. I'm very sure that you are concentrating and studying. Studying is a strenuous effort and it takes much energy. You need to take nutritious food. And Aunt has sent me the material that Jerome sir has provided. The study material is good. It's a very condensed version, but still there is no substitute to textbook. I strongly recommend uh, reading the textbook. I did not yet get the study material on organic chemistry, that is chapters from 6 to 10. Emma, when you talk
He
to,
didn't get, sir.
yeah, when you talk to mom, just ask mom to talk to Jerome sir and get the study material on organic chemistry also, so that, once we complete going through the important aspects from our textbook, then we'll quickly move to the study material that is given by Jerome sir. Okay. Basically, Janissa, the problems that were given in the textbook are very, very important. From these problems only, we'll get the questions. Okay. The solved problems as well as the unsolved problems. Yesterday, we were calculating problems. Of course, yesterday we could not meet. Mm, yeah, we were talking about the calculation of mole fraction, and that is a very important thing. And we have seen how to calculate the mole fraction of ethylene glycol in aqueous solution containing 20% ethylene glycol by mass. Sometimes, even standard textbooks will have some errors, and an experienced teacher like Jerome sir and myself, when we are with you, we can make you find the errors and enable you to not repeat the errors. For example, you see in this problem that we have uh, discussed in the last class, calculate the mole fraction of ethylene glycol in a solution containing 20% ethylene glycol by mass. The weight percent of ethylene glycol is 20%. From this, we will calculate the number of moles of ethylene glycol. And what we have to calculate is the mole fraction of ethylene glycol. Okay, mole fraction of ethylene glycol is equal to number of moles of ethylene glycol by number of moles of ethylene glycol plus number of moles of solvent. Emma, 20% means we know the number of moles from the information that the ethylene glycol is 20% in the solution. 20% by mass means 20 grams ethylene glycol, and the rest of 80 grams is solvent. It is water. It could be any organic solvent or something like that. Emma. So from that, we'll calculate the number of moles. Number of moles is equal to 8 by molecular weight, 20 by what is the molecular weight of ethylene glycol? That is not given, but we can easily calculate. How will we calculate the molecular weight? 2 into how many atoms are there? Carbon 2 atoms multiplied by atomic weight of carbon 12 plus number of atoms of hydrogen by atomic weight of hydrogen 1 plus number of atoms of oxygen multiplied by atomic weight of oxygen. 2 into 16 plus 6 into 1 plus 2 into 12. That gives a value of 62. So 20 by 62 is equal to 0.322. Okay, this many moles of ethylene glycol is present in the solution. And we should also find the number of moles of solvent. Okay. In the question, it is not very clear if the solvent is water. Such things will cause confusion. In the question, it should have been very clearly specified that it is aqueous solution. Provided
Sir,
the yes,
80 grams of water.
yes, Amma, 80 grams of water. We presumed that the solvent is water. But in the question, it's only mentioned that it is solution. It can be benzene. If I take benzene, the calculations will be different. Am I correct? If I take chloroform, AHF, I can choose ethanol as solvent. Am I correct? Solution means solute dissolved in solvent. The solvent need not be water always. So we should always specify the solvent what we are talking of. 80 grams of water, it could be 80 grams of ethanol. So in this case, only from the answer, we know that the solvent that is chosen is water. Emma. So in the question itself, such ambiguity should be avoided. 80 grams of solvent. What is the solvent? Water. So 80 grams of water means weight by molecular weight. Number of moles is equal to weight by molecular weight. Molecular weight of oxygen is 18 grams. 80 by 18 is equal to 4.444 moles. Then mole fraction of component A is equal to mole fraction of component A divided by mole fraction of number of moles of component A divided by number of moles of component A plus number of moles of component B. That is how we calculate the mole fraction of one of the components that is present in a binary system. Fortunately, we have only binary system. In ethylene glycol solution in water, the component A is ethylene glycol, component B is water. So we are calculating the mole fraction of ethylene glycol. So for calculating the mole fraction of ethylene glycol, what we need is the number of moles of ethylene glycol we have to calculate. Number of moles are simply weight by molecular weight of ethylene glycol divided by number of moles of ethylene glycol, that is solute, plus number of moles of solvent. Here it is presumed to be water. So 80 by 18. This calculation will give a value of 0.068 moles. Mole fraction. We know very well. In a two-component system, mole fraction of A plus mole fraction of B is equal to 1. Total sums up to 1, unity. Emma. So if we know the mole fraction of ethylene glycol, we can subtract that value from 1 and we can get the mole fraction of water. We need not altogether use the formula moles of water divided by moles of ethylene glycol plus moles of water. Okay. Simply, can you subtract 0.068 from 1? Can you please do this calculation, Janessa? 1 minus. Are you able to follow? Please do this simple calculation for me, Janessa. 1 minus.
1 minus
0.068.
0.932.
Exactly. Very good. Yeah, that's what is shown here. Mole fraction of water can also be calculated as 1 minus mole fraction of ethylene glycol. Simply, Emma, because we know very well that in a two-component system, mole fraction of A plus mole fraction of B gives rise to 1. Sum, total sum. Because, if you know that ethylene glycol is 20%, you know that the rest of the solvent is 80%. That is the indication we get from the unit called weight percent. Likewise, when we say mole fraction, it's a fraction, it's a ratio. Okay. In a two-component system, when the fraction of one component is 0.3, what is the fraction of second component? 0.7. That is how we will calculate. This is the simple concept about mole fraction. Then molarity. Definitely some questions will be asked on molarity, molality, mole fraction, Henry's law, Raoult's law, colligative properties. Especially these questions will be based on problems, Emma. So you should be thorough with the problems. What I recommend, Janessa, just take notebook and the solved problems in the textbook should be one after other rewritten on your notebook with all the steps, solutions. If we have some 20 problems, all the 20 problems you should do for yourself once again, Emma, so that you will be clear in your mind. All steps are understood. If any information is missing, where is the information that is missing? For example, let us come to this problem, molarity. Okay. We discussed that molarity means number of moles of solute per a liter of solution. So let us take up this simple problem. Emma, your mind should be fresh, your mind should be active. Of course, you are at the 11th hour, very active. I really appreciate your interest. I'm very sorry that I wasted your, nearly 38 minutes. There was, a great evangelist by name uh, Pastor DGS Dinakaran sir. Pastor DGS Dinakaran is a great evangelist from Jesus Calls Ministries. He used to record many sermons. One day it so happened that he went to the recording 5 minutes late, and then he apologizes to the videographer. I'm sorry that I'm late today by 5 minutes. That is the humility. Being such a great person, being the founder of Jesus Calls Ministries, DGS Dinkaranaya apologizes or says sorry for wasting somebody else's time. Likewise, today, I'm sorry that I wasted 38 minutes of time because of the problem with input, audio input. Audio input, my voice was not received. And so there was a problem and I could not reach out to you. Thank God that the link is still active. Zoom link is still active. Okay, moving forward, it's not how fast we go, Amma. Fastness is very important. I really agree with you, but it's also equally important that how much we are able to absorb. Okay. So let us go to the next problem. Can you read this problem, Janessa, for me? Is it visible? Example 1.2. Please read up.
Calculate the
Ah,
calculate the molarity of a solution containing 5 grams of NaOH in 450 ml of solution.
very good. NaOH is again solute. How many grams of solute is there? 5 grams. But for calculating molarity, we need moles. Moles of solute. Okay, ma? Again, moles is equal to weight by molecular weight. What is the weight of NaOH that is present? 5 grams. What is the molecular weight of NaOH? 40 grams. 5 by 40, 1 by 8. 5 8s 40. 1 divided by 8, how much? 0.125 moles. Okay. We know the number of moles. And number of moles divided by volume of solution in liters. Molarity of 5 grams NaOH in 450 ml. How will we convert 450 ml to liters? Ml
But
will be
1000.
converted to liters. So the conversion unit is 1 liter is equal to 10 power 3 milliliters. So divide by 1000. 450 divided by 1000 is 0.45. That is how we convert milliliters to liter. So number of moles of NaOH divided by 0.45 gives the molarity of 5 grams of NaOH solution in 1 liter of solution. Okay, ma? So the answer is 0.278 moles per liter or 0.278 moles per dm. What is dm?
Decometer.
Decimeter,
Oh,
millimeter, centimeter, decimeter. Emma, DECIMETR. So, because deci means, 10 ml, 10 ml, 10 ml, 10 ml, 10, 10, 10. Multiplied together, we get 1000 ml. That is why we can express in terms of decometer or decimeter. Can you please check, Amma, what is, I'll check in my phone. Decometer or decimeter.
no,
Sometimes
I'm not.
I will check. Because, these are not the regular units that we use. Decometer, dm is rarely used. So we should clarify by ourselves. Is it decometer or decimeter? Decometer is a device that can be used for navigation or to calculate diverse decompression status. Okay, ma, this is decimeter. This is not decometer. This is deci, millimeter, decimeter, like that. So now we have learned that how to calculate the molarity. Ma, this calculation of molarity, calculation of mole fraction, all these things will come for 1 mark question. Okay, how many 1 mark questions you have to write?
16.
Yes. So we should be very careful with the 1 mark question. A drop of water plus a drop of water plus a drop of water makes a tumbler full of water. Okay. Likewise, even small things, simple issues, we should record in our mind and practice so that we will not do a mistake. I'm very happy that you are still active. Yesterday, Aunt told that you are a bit sleepless and went to bed early. Then molality. Okay, ma. We discussed this problem of molality. And I told that unlike 1 liter of solution in molarity, here it is 1 kg of solvent, not solution. Emma, moles of solute divided by of solvent in 1 kg. You should never forget. Okay, ma. In this age, Janessa, in this age, you will have much potential to absorb. You can read faster, you can absorb more. So you should be very, very fast. You should be miles and miles ahead of me. Let us take one simple problem. Okay. For example, 1 mole per kg or 1 m solution. Small m denotes molality. Emma? For example, 1 kg per mole solution of KCl means 1 mole of KCl dissolved in 1000 kg of water. Have you understood, Emma? Molality? So if I say 1 mole per kg KCl means 1 mole means 74.5 grams of KCl dissolved in 1 kg of water, not 1 kg of KCl solution of water. You understood the difference? Yes, it's a bit sensitive. That is the basic difference between molality and molarity. Now let us see a problem on molality, because this can be asked for 1 mark question. Emma, one after other, we will see how best we can do. I'm sorry that I'm taking so much time. Calculate the molality of 2.5 grams of ethanoic acid. Ethanoic acid means ETH. Ethanoic acid means 2 carbons. Acid with 2 carbons is acetic acid, CH3COOH. How much of ethanoic acid is there? 2.5 grams. How much of benzene is there? 75 grams. Now, what is the molecular weight of ethanoic acid? I told you how to calculate the molecular weight of any compound. Number of atoms of a particular element into atomic weight plus number of atoms of second element plus its atomic weight. Like that, you have to calculate. You see uh, how the acetic acid molecular weight is calculated, Amma? Can you explain this, Janessa, to me? Molar mass of C2H4O2. How is this calculated?
Atomic mass is 12 into 2 carbon plus
Into two carbons. Yes. Yes.
1 is the atomic mass into 4 carbons.
Four.
And I mean 4 hydrogens
Yes.
and 2 oxygens into 16, which is the atomic mass.
Yes. So 60 is the molecular weight of acetic acid. Okay. Then from this, how are we going to calculate the molality? Molality is number of moles of acetic acid. From this molecular weight, how will we calculate the moles? We know that the amount of acetic acid that is present here is 2.5 grams. 2.5 grams divided by 60 gives number of moles of acetic acid. Then this many moles of acetic acid is present in 75 grams of benzene. Okay, ma. If 75 grams of benzene were to contain 0.04 0.0417 moles in 75 grams of benzene. So, X moles in 1000 grams of benzene. As per molality, the number of moles of solute present in 1 kg of solvent. 1 kg is 1000 grams. So let us cross multiply to get the number of moles of acetic acid in 1 kilogram of benzene. 1000 into 0.047 divided by 75 is equal to 47 divided by 75 is equal to, let me calculate and see. It's only a revision, Amma. Already you know all these things. We are recapitulating. We'll go to the study material that mother has sent. 47 divided by 75 is equal to 0.626. Where are we going wrong? 0.0, okay. It's number of moles is not 47, 417. Okay, ma? It is 417. It is 41.7. You see here, number of moles is 0.0417. 0.0417 into 1000 divided by 75 is 41.7 divided by 75. 41.7 divided by 75 is equal to, yes, 0.556. Okay, ma? This is
Yes.
this is molality. Okay. Calculate the molality. Molality is represented in small m. Okay. Moles of acetic acid per kg of benzene. Is this problem clear, Emma?
Yes, sir.
Very good. Now, let us see these problems, Janessa, only from your textbook you will get the problems in the question paper. You should be writing down all the solved problems and unsolved problem also you should do. If you cannot solve any problem, just message me and I will solve the problems and send it to you. Anything, any chapter, Emma, any questions if you find it difficult. You see, now we have some 20 old question papers. We will discuss them one after other. In the 20 old question papers, you should be spending time and reading one mark questions, all one mark questions in the 20 papers together. Let us finish one mark questions. Then let us go for 2 marks. Like that, you should take up and study, solve the papers so that you will be very confident in addressing all the 16-mark questions. Yes, from any of the 10 chapters, any objective question I can solve. You will have basically only objective type questions, multiple choice questions, A, B, C, D. In that multiple choice questions, in that objective questions, there will be matchings also. There will be assertion followed by reason, and you should be able to answer one of the 4 questions if the reason is related to the assertion. If both the assertion and the reasoning is true, are true. If only assertion is true and reasoning is false, the next option will be the reasoning is related to the assertion. The reason correctly explains the hypothesis. These are all the 4 objective A, B, C, D, multiple choices you have. This type of questions also will be asked. So you should be very, very familiar with the question papers. That is very important. I have seen the material that sir has sent. Jerome sir has sent. It is very condensed, Amma. It is very nice. But still, why I insist on reading the textbook is from this, it's necessary that we revise. What Jerome sir has sent is last minute revival, last minute revision. Just before our exam, 1 week before, we will read all those things. But prior to that, we should have a solid foundation, confidence on all the problems that are present in solutions, followed by electrochemistry, followed by chemical kinetics, followed by D block and F block elements, and then coordination chemistry. Today, Aunt has sent me the material on coordination chemistry, and basically one important question from coordination chemistry is the nomenclature. Emma, inner sphere complexes, outer sphere complexes, uh, um, then crystal field stabilization energy. How do we calculate the crystal field stabilization energy? Okay. Then that depends on, tetrahedral and octahedral geometry, and low spin complexes and high spin complexes, how the low spin complexes gets the electron distribution in their d orbitals. In high spin complexes, how the electron distribution takes place depending on the electron distribution in the orbitals dxyz and dyz, Emma, based on the distribution of these orbitals. It will be reverted based on the geometry, tetrahedral geometry or octahedral geometry. Those spin or what is that? Crystal field stabilization energy calculations we should do. There will be definitely one question on how to, what is the crystal field stabilization energy? Crystal field theory. We have to explain the crystal field theory. And also there will be some question on the nomenclature of inorganic complexes, how the inorganic complexes are to be named. We'll be given a set of formula and we have to name the oh, in 10 more minutes it is going to be completed. So let us try to move as much forward as possible, Amma. Let us see another problem. Okay, calculate the mass percentage of benzene and carbon tetrachloride in 22 grams of, if 22 grams of benzene is dissolved in 122 grams of carbon tetrachloride. Okay, Ma. Here, have you understood the question, Amma? Here, again, I told you concentration of solutions is a very important problem, and there are various ways of expressing the concentration of solutions. And one of the simplest way is weight percent. Mass percent is same as weight percent. Here we have two components. One is carbon tetrachloride. Carbon tetrachloride has a chemical formula of CCl4 and benzene. Here in the two component system, the carbon tetrachloride amount is 22 grams and benzene amount is 122 grams. So please tell me now in this solution, what is the solute? Carbon tetrachloride, because carbon tetrachloride amount is relatively smaller compared to benzene. In a solution, the amount that is present in relatively small amount is called solute. In a solution, the amount that is present in relatively large amount is called solvent. So the solvent in this solution is carbon tetrachloride. Sorry, the solute in this solution is carbon tetrachloride, and the solvent in this system is benzene. Now the question is like this. What is the weight percent of CCl4 in this solution containing 22 grams of CCl4 and 122 grams of benzene? Like dissolves like. This is the simple principle our chemistry teachers have taught. Emma, because you know, Janessa, your mind and my mind are matching. That is why you said, Grandma, why do you say to sir the time? Let sir decide. Aunt was so polite and telling me that you are very much available at my convenient time. I'm very thankful to you, Amma. Really, I appreciate your concern for me. I'm so busy, Amma, but still, by taking each class, before taking each class, I prepare. Today, I prepared for you about, the Le Chatelier's principle, the Henry's law, the Raoult's law, standard electrode potentials, redox potentials, electrochemical reactions. Even an experienced teacher like me, I need to come down to the basics, when I was teaching at GSFC University during 22 to 23, that is a different thing. Now, I'm not into that. I'm more into, research. I'm more into writing papers. I'm more into writing grant applications, writing books. These are the fundamental aspects. Again, I have to come down and brush up the, fundamentals and teach you. Come down to the school level, college level. I'm very happy, it's a kind of revision to me. Ma, way back in 1990s, every day I used to teach for hours to school-going children and college children and even to BSc children, BSc college students. even, in Andhra University, there used to be a chemistry teacher by name Murali Krishna sir. He had his postdoctoral research from Lawrence Berkeley Laboratory. He's an expert in radio analytical techniques, and he's such a humble person that he requested one fine evening, Indranil garu, మా అబ్బాయి కాలేజ్ లో చదువుతున్నాడు, ఇంటర్మీడియట్ సెకండ్ ఇయర్, మా అబ్బాయికి మీరు కెమిస్ట్రీ టీచ్ చేయగలరా అని చెప్పి అడిగారనమాట. సారే కెమిస్ట్రీ టీచరు, ప్రొఫెసరు, ఆయన నన్ను అడగడం ఏంటి? ఐ వాజ్ సో హ్యాపీ టు సీ హిస్ హ్యూమిలిటీ. తప్పకుండా చెప్తాను సార్ అని చెప్తే, వాళ్ళ అబ్బాయి పేరు అశోక్ అనమాట. మీలానే చాలా మంచి అబ్బాయి అనమాట. హీ ఈస్ సో డౌన్ టు ఎర్త్. అస్సలు హీ హాస్ నో ప్రైడ్ ఎట్ ఆల్ దట్ హిస్ ఫాదర్ హ్యాస్ బీన్ ఎ ప్రొఫెసర్ ఇన్ ఆంధ్ర యూనివర్సిటీ క్యాంపస్, అండ్ హిస్ ఫాదర్, వాళ్ళది మంగళగిరి, గుంటూరు దగ్గర అనుకుంటా మంగళగిరి. He's such a humble person, and to him I thought, transition elements, rare earth elements, D block chemistry, inorganic chemistry. I recollect such great students that I had in my career. Likewise, when I was in IIT Madras as a scholar now, way back in 2002 to 2010, there used to be another great teacher by name Professor అశోక్ కుమార్ మిశ్రా సార్ అమ్మా. అశోక్ కుమార్ మిశ్రా సార్ అని కెమిస్ట్రీ టీచర్ అనమాట. హీ సచ్ హంబుల్ పర్సన్, వన్ ఫైన్ ఈవినింగ్ ఆర్ మార్నింగ్, ఐ డోంట్ రిమెంబర్, హీ టోల్డ్ మీ, Indranil, my son want to learn about polyoxymetalates for some science competition. Can you instruct him? Can you teach him on these particular materials? I'm so much moved that, being such experts in chemistry, they are so humble to ask me to teach their children chemistry. Uh, it's God's grace. Okay. I'm so much indebted to Aunt, so I want to spend some time with you to brush up the fundamentals, to revise with you, to teach you, and to motivate you. Basically, అమ్మా ఎందుకు నేను మీతో టైం స్పెండ్ చేస్తున్నానంటే, I want to inspire you, I want to motivate you, and I want to tell you how beautiful the future is. Once you complete your college, life is beautiful, Amma. You can choose chemistry as your career, and I want you to be a great scientist in chemistry. After BSc, you should do MSc chemistry and then move abroad for your PhD. Life is so beautiful. I enjoyed my stay in Israel for 6 long years, and then in Korea for 1 year, and then in China for 2 years. How I go? How could I go? It's something somewhere like, when I was a young person like you, I was determined to choose career, chemistry as my career. I was working very hard, waking up early at 4:30 in the morning, and reading the material that my teacher, Sridevi Nagarajan sir, has given, madam has given. Like my teachers, your teachers are very dedicated. Jerome sir has given the reading material, Amma. We may not be surprised if Jerome sir might be one of the panel members to set the question paper. Uh, it can happen. So when he sets the paper, what he will do? He will choose the questions from the material that he has given. So that's how it is. So the material that is taught in the school, Velamal College, should be revised thoroughly, but that should be the last minute effort. Okay. So now that we have some time, I'm going through each of the problems and telling you the fundamental aspects so that you can know from where you can expect the questions. The solved and unsolved problems in each chapter should be imprinted in your mind. Okay, once you are thorough with each of the steps of these problems, confident with the fundamental concepts, then it will be much more easier for you to glance through the study material that Jerome sir has sent. Emma, sir might be preparing the study material for unit 6, 7, 8, 9, 10, probably Monday when you, Tuesday when you go to college back, you will be given the material. When can I expect? Okay, tomorrow and day after tomorrow, I take the classes, Amma, no problem. I'll try to spend more time tomorrow and day after tomorrow, because Tuesday morning, I aren't told that you are leaving. After Tuesday, when can I expect you back home?
Uh, I will come only after board exam.
Acha. Okay. I really wish you well, Amma. I continue to pray. Aunt and myself will be praying for your thorough success. You are a great, student, and brilliant. God has blessed you with grasping power and brilliance. But once you are in college, I don't think I can have such time to interact with you. Do you think it is possible for me to contact you through is it possible? That will be great. Huh? Let us see. Even when you are in college,
So the meeting is going to end.
okay. No problem, Mama. Tomorrow, what shall we do? Uh, please go through the 20 question papers I have given you, Amma, and try
Mm.
to read this unit 1, unit 2, unit 3, unit 4, one after other, with emphasis on the problems, okay? With emphasis on the things that are given in bold. Amma, I wish you